today's class we are going to see one diagonalization problem. How we are going to do that diagonalization. Suppose the given matrix, we are going to deal with a 3 by 3. So let's consider that a given matrix is equals to 4, 1, minus 1, 2, 5, minus 2, 1, 1, 2. Already the steps how we are going to follow that diagonalization steps I made as in a shorts only for the steps. In that short only it's talking about the steps, what all the steps we have to follow for doing the diagonalization. Find the diagonalization of this one. Find the diagonalization of given matrix. This is the matrix. First step, what is the first step? We are going to find the eigenvalues. First characteristic equation will go. Characteristic equation mod of A minus lambda I, which is equals to 0. That is the given matrix minus lambda I. So 4 minus lambda 1 minus 1, 2, 5 minus lambda, minus 2, 1, 1, 2 minus lambda, which is equals to 0. Along with me, you also take a pen and paper and solve it. Then only you are going to learn that mathematics very easily. If you are going to listen, you won't get anything. So practice makes man perfect. So along with me, you also take one paper and pen and solve it. Find the determinant of this one. What you are going to get? 4 minus lambda, 4 minus lambda into this matrix, where this row and this column will get cancelled, left with these elements. That is equals to 5 minus lambda, minus 2 lambda, then this is equals to minus of n minus, it's a plus 2. Then next what you're going to get, next is equals to minus 1 of, then minus 1 of, then see again you are this one, this column and row will get cancelled. You are left with 2 minus 2, 1, 2 minus lambda. So what you are going to get over there? 2 of 2 minus lambda, minus of and minus, it's a plus 2. Next it's minus 1, again you see here. It's a minus 1. So this row, this column and row will get cancelled. You are left with these elements 2, 5 minus lambda, 1 and 1. So with that what you are going to get? It's equals to 2 minus 1 into 5 minus lambda, which is equals to 0. When we are going to solve this one completely, we are going to obtain one polynomial equation. After solving this completely, we are going to get one polynomial equation. That equation directly I am writing lambda cube minus 11 lambda square plus 39 lambda minus 5, it's to 0. Then you have to find values here. Lambda cube minus 11 lambda square plus 39 lambda minus 45, it's equals to 0. It is a maths class, not a physics class. Then after that, by using that synthesis method, we can find the values. Synthesis method everyone knows, because you will be learning from school. What is the coefficient of here? Even though again I am saying, what is the coefficient here? It's a 1. Then next is 11. Next is 39 minus 45. So here we have to make this last element is equals to 0 by making the substitution of the values. And moreover, When it is in lambda cube, we'll fall into the quadratic form so that we can find the roots of that value. So here 45 is there. Directly I will move with the 3, and let's check it out whether with the 3 this last element will become 0 or not. So first we'll write over here, then we are going to add 1 plus 0. It's a 1. Then next is 1 into 3. Again we are going to write in an opposite direction, 3. 11 minus 11 plus 3 will give you minus 8. Then minus 8 into 3 minus 24. Again you add this one. So after adding this one, how much we're going to get? It's a 15. Then 15 3s are 45. So this term it's equals to 0. This is the one root that we are going to write. This when we are going to take this 3 on this side, it's going to be lambda minus 3. Next this will be square place, lambda square minus 8 lambda plus 15, it's equals to 0. Lambda minus 3, it's equals to 0, or lambda square minus 8 lambda plus 15, it's equals to 0. Lambda is equals to 3. This is one root, it's completed. Now here by using the common factors we can make out this 8 you have to split in such a way that this constant also should come. So this 8 I can write minus 5 and minus 3. I can split this 8 into minus 3 and minus 5, so that with the help of the common factors I can find the roots. So lambda square minus 5 lambda minus 3 lambda plus 15, it's equals to 0. From these two terms, which is a common? Lambda is a common. So lambda of lambda minus 5, then minus, yes, middle term only we will split in such a way that constant, when you are going to take a common factors, that constant also has to be covered. So from these two terms you see, for if you take 3, I am going to get here lambda, then minus 5. Minus 5 into minus 3, again I am getting back as a 15. It's equals to 0. So lambda minus 3, next is then from this two common factors, from this common is what? Lambda minus 5 is a common. So lambda minus 5, it's equals to 0. So what roots I am getting here? Next is lambda minus 3 is equals to 0, or lambda minus 5 is equals to 0. Lambda is equals to 3 and lambda is equals to 5. So how many roots I got here? Where I got 3 roots, because the order of the matrix is 3 by 3. So we are going to get 3 values as eigenvalues. So lambda is equals to 3, 3 and 5. These are known as eigenvalues. So first step of the diagonalization, it's completed. We have find the eigenvalues. Now for these eigenvalues we have to find the eigenvectors. So how we are going to find the eigenvectors? First case 1, when lambda value is equals to 3, and we got lambda values is equals to 3 and 5. So here no need to find the eigenvectors for this value. Only once time we are going to solve, not as in a double time, because whatever the operations we are going to utilize, it's not going to change, it's going to remain same. So your a minus lambda I into x1, it's equals to 0. This is as a vectors. So that matrix is what? 4 minus 3, 1 minus 1, 2, 5 minus 3 minus 2, 1, 2 minus 3. x1, x2, x3, which is equals to 0. We have substituted, this is your lambda values. Lambda is equals to, how we are writing as an A minus lambda I. I is your identity matrix. Then after that, what you are going to get? 4 minus 3, it's 1, 1, minus 1, 2, 2, minus 2, 1, 1, minus 1, x1, x2, x3. It's equals to 0. Now with the help of the row operations, I am going to apply here echelon form. In echelon form, we have to make these elements, the lower triangle, we have to make it equals to 0. And when we are applying, we have to see that you should not going to get a trivial solution. Every time when you are going to find the vectors should become under non-trivial solution, because vectors cannot be equals to 0. Now what operations we are going to apply for making that is equals to 0? With the help of the row 1, first I will make these two elements is equals to 0. So your R2 tends to R2 minus 2 R1, because for making this is equals to 0, I need a minus 2. And that I am taking the help of the first row. For the first row I am multiplying with 2. Then next you are making this is equals to 0. R1, R3 tends to R3 minus R1. 1, 1, minus 1. This is equals to 0. 2 minus 2. It's a 0. Minus, next is equals to minus 2 plus 2. It's equals to 0. Next is 1 minus 1. 1 minus 1, 0. 1 minus 1, 0. 0. x1, x2, x3, which is equals to 0. What is the rank of given matrix here? What you got the rank? Rank of A, it's equals to 1. And how many unknowns we are having? 3 unknowns we are having. These are the unknowns. So solution will be based on your solution which is equals to rank of A. Solution is equals to number of unknowns minus rank of A. So what is how many unknowns we are having? 3 unknowns we are having. It's equals to 3 minus 1. It's equals to 2. So for this case, we are going to get 2 solution. The solution, the given matrix, whatever the matrix we had here, after applying the row operations, this is fall into which one? Non-trivial solution. We are going to get non-trivial solution. The system possesses non-trivial solution. So your solution is equals to 3. You are going to obtain 3 solution. First we are going to write this first row into the equation form. So x1 plus x2 minus x3. x1 plus x2 minus x3, which is equals to 0. Make this equals to equation number 1, where 2 solutions are there. So we have to assign any 2 values, arbitrary constants, either x3 or x2 or x1 or x3 or x1 or x2. You are going to assign any arbitrary constant. So I will take let x1, let x2 it's equals to k1 and x3 it's equals to k2. We will substitute this into the first equation. Substitute above values in equation number 1. So what you are going to get when you are going to substitute into the equation number 1, we are going to obtain x1 plus k1 minus k3 it's equals to 0. So x1 it's equals to minus k1 plus k2, where your first solution, the first vector x1, it's equals to x1, which is equals to x1, x2, x3, which is equals to, where x1 is equals to minus k1 plus k2. Next k2, k2 is equals to k1, then k3, it's equals to k2. See how we are going to get a 2 solution from here. When we are going to separate the k's, is equals to, first I will take k1 elements. So from here I am going to get minus 1, from here 1, and here there is a no k1. So this is equals to 0. That is equals to 0. Next, plus k2. So from here first one, 1, and here I am not having any k2 value. So it is equals to 0. Then k2, it's equals to 1. So this is what called as a 2 solution. This is your first vector. Now after that, what we are going to do, we are going to find for the second vector when lambda is equals to 5. Second case 2, when lambda 2 it's equals to 5. So the matrix will get reduced to, what we are going to get, 4 minus 5, 1 minus 1, then 2, 5 minus 5 minus 2, 1, 1, 2 minus 5, then x1, x2, x3, which is equals to 0, which is equals to, now 4 minus 5, what you are going to get, 4 minus 5, it's equals to minus 1, then 1 minus 1, 2, 0, minus 2, 1, 1, minus 3. Then next is x1, x2, x3, which is equals to 0. Now again we are going to apply the echelon form only. We will make lower triangle is equals to 0, or otherwise you can go with the statistical method. Here we are applying the echelon form, so we will apply echelon form only. So what operations you are going to write? For making this 2 elements is equals to 0, we are going to take the help of first row, where the first row element is equals to what? It's equals to minus 1. Right. So you are going to get your operations is going to R2 tends to R2 plus 2 R1, then R3 tends to R3 plus R1, because R1 it's a minus 1. That's the reason the operator it came here plus. It's equals to minus 1, 1, minus 1. Then this is going to be 0, and this is equals to 2 and minus 4. 1 minus 1, 0, 1 plus 1, it's a 2. Then minus 1, minus 1, minus 1, minus 3, minus 1, it's equals to minus 4. Then x1, x1, x2, x3, which is equals to 0. Now this is not in echelon form. I have to make this element is equals to 0. For making this element is equals to 0, I am going to utilize R2. If I am going to take a help from R1, this will not become a 0, or it can become as a 0, but this element will appear here. Then there is a no meaning. So once this is got into the standard form, we are not going to touch that row. You have to play the game. For making this element is equals to 0, you have to utilize R2. So with the help of the R2, we are going to make this element is equals to 0. So what you are going to get from here, which is equals to what operation you are going to write? Your R3 tends to R3 minus R2, which is equals to minus 1, 1, minus 1, then 0, 2, minus 4, 0, 0, the next is equals to 0, x1, x2, x3, it's equals to 0. What is the rank of A? Rank of A, it's equals to 2. So what you are going to get the solution here, where your solution which is equals to number of unknowns minus rank of A. So solution is equals to number of unknowns is equals to 3, rank is equals to 2, it's equals to 1. So you are going to get only one solution. The system possesses non-trivial solution. Don't forget to write this one. The system possesses non-trivial solution. First, write it into the equation form. Whatever you got, write it in the equation form. So what you are going to get into the equation form, first one, it's minus x1 minus x1 plus x2 minus x3, it's equals to 0, then 2x2 minus 4x3, it's equals to 0. This is equation number 3 and this is equals to equation number 4. Now we will assign let x3 it's equals to k. Substitute in equation number 4. So 2x2 minus 4k it's equals to 0. Then 2x2 it's equals to 4k, 2 1s are 2 2s are x2 it's equals to 2k. Now we are having the two values, we are going to substitute in our third equation. This is our third equation. Here we are going to substitute minus x1 plus x2 minus x3 is equals to 0. Here we are going to substitute that x2 and x3 values. So what you are going to get when you are going to substitute that one, which is minus x1 plus 2k minus k it's equals to 0, minus x1 then plus k it's equals to 0, x1 it's equals to minus k. Now next, your second vector, what you got for the second case, because we got lambda is equals to 3 and 3, so one time only we have solved. Next we have solved for lambda is equals to 5. So second one lambda, or you can take it as a 3 lambda, because for constructing the model matrix we need it's equals to x1 x2 x3, which is equals to, where x1 is equals to minus k, then next x2 it's equals to 2k, x3 it's equals to k. So from here we are going to take k as common. K it's equals to minus 1, 2, 1. This is your vectors. This is known as eigenvectors. Now third step is what we have to construct the model matrix. Whatever the eigenvectors we got, first vectors what we got for a lambda, when lambda is equals to 3, we got two cases. K1 that was what, minus 1, then 1 0, then plus K2 1 0 1, and for lambda is equals to, for lambda it's equals to 5, we got that is equals to k of minus 1 2 1. With the help of these vectors we are going to construct the model matrix. This will take x1, this is x2 and this is x3. So your model matrix model matrix P is equals to x1, x2, x3. So as it is, how these are there, like that only you have to dump here. So your P is equals to P, which is equals to minus 1, 1, 0, 1, 0, 1, minus 1, 2 and 1. Next, 2 steps are completed. 3 steps are completed. After that, what we are going to do, we are going to find the P inverse. With the help of the calculator also you can find, or by using inverse method, or by adjoint A by det A. So finding P inverse. Find P inverse. P inverse, directly I am writing that one by using the calculator. You will get your P inverse, which is equals to, you are going to get P inverse is equals to minus 1, 0, 1, minus half, 3 by 2, then 1 by 2, 1 by 2, minus 1 by 2. Then after that, for finding that P inverse, we'll move for finding the, or checking for the orthogonality, whether it's going to be orthogonal or not. If it is orthogonal, then only the diagonalization will exist, otherwise it won't. Diagonalization means what? The principal diagonal only going to lead with the eigenvalues, where upper triangle and lower triangle is going to be completely 0. For checking for the orthogonal, to find orthogonal, P into P inverse, it should be equals to I, where your P is equals to, where P it's equals to minus 1, 1, minus 1, 1, 0, 2, 0, 1, 1. Then into P inverse, where P inverse is equals to minus 1, 0, 1, minus 1 by 2, minus 1 by 2, 3 by 2, 1 by 2, 1 by 2, minus 1 by 2. Rows into columns. Everyone know how to do the matrix multiplication. Rows into columns. When we are going to do rows into columns, we are going to obtain, when we are going to do rows into columns, we will get that matrix P into P inverse, which is equals to 1 minus half plus half, 0 minus half plus half, minus 1 plus 3 by 2 minus 1 by 2, minus 1 plus 0 plus 1, then 0 plus 0 plus 1. Next will be 1 plus 0 minus 1, 0 minus 1 by 2 plus 1 by 2, 0 minus half plus half, 0 plus 3 by 2 minus 1 by 2. Right? Then you are going to get, see here, minus half plus half will get cancelled. This is completely 0. This is 0. This is 0. 1, 0. 0, 0, and this is equals to 1. 3 by 2 minus 1 by 2 will give you 2 by 2. 2 by 2 is equals to 1. So our orthogonality is got existed. So we can move for finding the D, where P into P inverse, which is equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. So P into P inverse is equals to I. It's done. Now next we'll go for finding the D. D is equals to P inverse A into P. And moreover, when you are going that matrix multiplication, don't do P inverse into P is equals to I. No. First complete that AP. Whatever the resultant you are going to get for the matrix multiplication of AP, then you are going to do that resultant matrix multiplication with P inverse. That should be equals to your eigenvalues, where your D, which is equals to P inverse it's equals to minus 1, 0, 1, minus 1 by 2, minus 1 by 2, 3 by 2, 1 by 2, 1 by 2, minus 1 by 2. Then A matrix, which will be the given matrix, that is 4, 1, minus 1, 2, 5, minus 2, 1, 1, 2. Then P. P matrix is equals to minus 1, 1, 0, then 1, 0, 1, the next 1, 2, 1. 1, minus 1, 1, 0, 1, 0, 1, 1, 2, 1. Right. Next, first you are going to finish off the matrix multiplication with this. Rows into columns. When we are going to do rows into columns, this matrix as it is you dump here. Minus 1, 0, 1, minus 1 by 2, minus 1 by 2, 3 by 2, 3 by 2, then 1 by 2, 1 by 2, minus 1 by 2. Next, when we are going to do the matrix multiplication of these two matrices, we are going to obtain minus 3, 3, 5, 3, 0, 10, then 0, 3, 5. Then after getting this matrix, you have to do the matrix multiplication with these two matrices, rows into columns, which is equals to, we are going to obtain 3 plus 0 plus 0, minus 3 plus 0 plus 3, minus 5 plus 0 plus 5, 3 by 2 minus 3 by 2 plus 0, minus 3 by 2 plus 0 plus 9 by 2, minus 5 by 2 plus 10 by 2 plus 15 plus 15. This will be minus 10 by 2, 15 by 2. Next will be, next for the last one, it's going to be minus 3 by 2. The last one, minus 3 by 2 plus 3 by 2, then it's equals to 0. Next will be 3 by 2 plus 0, minus 3 by 2. Next is equals to 5 by 2 plus 10 by 2 minus 5 by 2. So what you are going to get, see here, this is 3, this is 0, 0, this is equals to 0, 3 by 2, 9 by 2. Will give you 6 by 2, 6 by 2 divided by 6 by 2, it's equals to 3, then this will get 0, 0, this is 0. Now plus 5 by 2 minus 5 by 2 will get cancelled, 10 by 2 will give you the 5, which is equals to your eigen values. We are going to get D is equals to 3, 0, 0, 0, 3, 0, then 0, 0, 5. This only the eigenvalues we got. See the principal diagonal, it's leading with your eigenvalues. You can justify your answer whether all your steps is correct or wrong, because you should get diagonalization means the principal diagonal should lead with the eigenvalues. Upper triangle and lower triangle should be 0. This is the method for finding the diagonalization. Thank you for listening to me. If you are having any kind of doubts, you can leave the doubts in the comment. In the next class, I will clear it. Thank you.